Hello, everyone. Let me set this up before before we start. Of course, it stops working. Um, we're gonna restart this, and I'll be fine. Okay, so I want to show my iPhone so you can see how this works. Cool. Yes. There we go. Dun, dun, dun. It's running. It's running. Ah, there we go. Why can't I see it anymore? Oh no, I'm so sad. Well, I guess you'll have to trust me. Maybe maybe if I turn this off and this off. One more try, one more try. Okay, while this is trying to connect. Hi, everyone. I'm Daniel. Is this working? No, it's not working. It's so sad. We'll try later. So I'm Daniel. I'm Daniel here. So that's me at Vox Zurich last year. This is me at Vox Zurich this year. I work for Broadcom. Last year it was VMware, but we got acquired in the meantime. I work in the Tanzu Spring org. So we do a little bit of Tanzu application platform work where I do SSO stuff. And in the Spring world, I do Spring security. So I do, SSO, I do OAuth and this kind of things. Here are my socials and email. Feel free to reach out. I always take the time to answer questions, even though it might take me a couple of days, but I have enough bandwidth that I can chat with all of you. First, before we go into the deep end of the technical stuff, I want to take a minute to thank the sponsors. They are the reason I am here, right? And the reason you are here on reasonable prices. None of this would be possible without them, so I'm very grateful and I'm glad they're here to help us out. All right, so WebAuthN. We're going to talk about passkeys and WebAuthN today. Who has ever heard about WebAuthN and passkeys in the room? 30%, 40%. Who actually uses passkeys? 1, 2, 3, 4, 5, maybe 10 people? Okay, passkeys are cool. You should try and use them. So let me show you how this works. If I can make this work, I'm not sure. Okay. Try and share my screen. Where is it? Where are you, our server? There you go. So is this working? So I have signal, but it's black, so I can't really show you. Maybe with photo booth. Let's hack it. Okay, so here can you, no, we can't see it. Oh, I can show you this here. Yes, I can somewhat show it. It's a bit too short, too sad. But the idea of passkeys is passwords have problems, right? You reuse them, they get lost, they get leaked, they get stolen, and so it's not the most secure thing in the world. And the idea of passkeys is going to be doing something like SSH, but for logging in. And we don't want you to remember your private key, and we don't want you to run crypto manually if you're a normal user. So the idea is that we're going to give you one of these physical devices, or your phone. Your phone is a passkey as well. And using that, you will be able to log in. So here this says sign in with passkeys. So there are multiple ways I can do this. Can I show it? Can you see the blinking light here? Okay, so if I click this here on my GitHub account, it tells me what's your PIN. So I need to know so that when you steal my device, you're not able to just log it in. But if I have the PIN to this device, I click and I'm logged in. I can do the same with, close that one. I can do the same with my TouchID sensor that's here. So sign out. And then when I click here, I have registered this Mac as a passkey. So with just one finger click in here, it does biometrics and it logs me in to GitHub. And the really cool stuff is having this kind of passkey authenticator, which is my phone. And doesn't need to be connected, it just needs to be available over Bluetooth and be able to talk to my device. But if I click here and I say I want to sign in with passkey and I want a device that's close to it, And I can click this, and with my phone, which I can't show you unfortunately, I can scan that QR code, right? And my phone will tell me, hey, you want to connect to GitHub.com using this account. Please do FaceID. So I do this. I hold it to my face, and then it connects over Bluetooth. And using crypto, I log in without password. So it does multi-factor authentication. It's something that I have, and it does biometrics, something that I am, without passwords. And this is something you can implement yourself in your own apps. So before we get into how it works, a little bit of the terms, important terms. WebAuthN is a spec from the World Wide Web Consortium. It's a nice little piece of work that is absolutely easy to read and understand, right? You have 250 pages, I think, if I remember correctly. No, 204 if you zoom in, of which I've read about, I think, 70. And it basically tells you, or it tells browser implementers and passkey implementers how to put some JavaScript in your browser so that you can start an authentication flow with one of these secure devices. An authenticator is a cryptographic thing. It can be hardware, like these keys here, or it can be software. And it allows you to generate credentials for a website and prove that you have those credentials. A passkey is a special case of an authenticator. It's an authenticator that can be discovered by the browser, right? So you don't need to know its ID or anything. When you say, I want to log in with a passkey, it starts blinking and you can click on it. And then, has any of you here heard of FIDO2? FIDO, yeah, right? Does anybody know what it is? Kinda, right? So FIDO2 is actually, it's a bag of standards. Where we have the WebAuthN standard and also the standard for manufacturing these authenticators. So the protocol, the hardware side of the protocol, and it's made by the FIDO Alliance, which is Google, Apple, and Microsoft. Okay, but basically today we're not going to manufacture an authenticator. We're going to connect our website to a passkey. So we're going to be doing WebAuthN. Okay. So how does it work? As I've hinted when I mentioned it, it works with asymmetric cryptography. So there's a public key and a private key pair that's generated on the device for a given website and a given user. And this is used to log in. Does everybody know here how public-private key works in general? Does anybody need a refresher of this? No, nobody. So I can skim through this, right? Alice generates a public key, a private key, distributes the public key, keeps the private key private, and then use the private key to sign some content she wants attested to prove that it was generated by her. She distributes the content along with the signature. The signature can be verified by the public key. If an attacker tries to impersonate Alice, they can't produce the same signature, right? They could produce a signature with a different key, but they wouldn't match and it would be rejected, right? So this is what it does. And there are two important phases of the protocol you can do with WebAuthN. So the first one is registration. It means you're going to basically take your physical authenticator and make it known to the website. And so the authenticator will generate a private key that is only valid on this website for this user. And it is going to share the public key with the website over HTTP, right? Once the website has your public key, in the future when you come back, the website can ask you to prove your identity, and you can prove it by using your private key, signing some sort of message, sending that message to the website. The website validates the signature of the message with the public key. It knows about you, and so you're authenticated, all right? So if you go to the spec, you have these beautiful diagrams that are completely very, very hard to understand. So instead, I'm going to do kind of a step diagram of what happens. In both ceremonies, both registration and authentication, it kind of works the same, even though the final data isn't exactly the same bits. But the server is going to create a challenge, a random string, that it attaches to your session, send it to the browser. The browser is going to call credentials.create, so the web API that's been introduced by WebAuthN, or credentials.get, using that challenge. The authenticator will be triggered by this, right? And then it will prompt the user for verification. So are you okay to try and sign in with this website, or are you okay to try and create credentials for this website? And it needs interaction from you most of the time. So the idea is at least it needs your presence. So you need to click on a thing so that no malicious website can send many requests to your authenticator and try to guess your private key. But it can also verify your identity using biometrics, using a PIN, using any other method that's going to be invented in the future. So when you agree, you click the button. The authenticator is going to either generate a key pair if you're registering, or just sign the challenge. And then it's going to give that to the browser, which is going to send it back to the server, right? So in the server is going to either save your public key or just check the signature that you have produced with your private key against the public key that it knows for you, right? Okay, enough. That's all I have for slides. So now let's do a bit of code. I want you to take a minute to look at these cats, because I have one more slide I lied, and it's going to be something like this. So, much less cute. So keep the cats. Very nice. Yes, good. All right. So let's code and let's do this. I have an app, of course, that starts with not much. And in here, if Docker is running, this should start. So this is a Spring Boot application. And this app already has passwordless authentication implemented, but not with a passkey yet, because we're going to do this together. How do we do an authentication without a password? Like, this has existed for decades now. Does anybody know how can verify the identity of a user without their password? No? No idea? It's also used in other flows, in the reset password flow, right? When you reset the password, you still verify the identity of the user, and then you make them create a new password. Any idea? Magic links, email, yes, exactly, right? So the idea here is going to be, let's go to localhost, right? So I have my app here, and I'm going to create an account. So Daniel@VoxDayZurich, and my email is going to be daniel@example.com, right? Is the font size all right? Okay, complain if it's too small. And so now my account is created, and so I can exercise my email. Of course, I use a totally real email provider. When I click on this, I guess it's in Do Not Disturb. My demo is blowing up. Is it? No, it shouldn't. Try again. Wow, this is not great. My notification is not coming around, so I'm going to cheat. I'm going to print it. It's fine. Mail notifier. Wow, demo not working today. And I am going to print the link here in the console. So this should give me a pop-up, but apparently it doesn't want to. So let's do without. Okay, Daniel@example.com. Okay, in my console now, I wanted to do something cooler than this, but I get an email, a link. So this link, you would receive it by email, right? And so when I click on it, I'm logged in with my username and password. And now I don't have passkeys registered yet, right? Because this is what we're trying to do together. And so what we want to do is register a new passkey. So there's a little bit of infrastructure ready, right? There's the HTML, and if I try and add a foobar passkey and I click register, it just brings up a pop-up that says, you've clicked register passkey with foobar, and now we have to write the JavaScript for this to actually trigger the blinking authenticator here. Okay, so how do we do this? So I could go to the HTML file myself on the account page here, and in the script, in this register passkey script, I could start typing stuff, but that's not how I would do it in real life, because it's too complicated. I don't know this by heart. So instead, I would go to the internet. And one good resource for this is the actual spec. So the spec here, it's long, it's complicated, but the introduction has samples and sample scenarios. So you can go and see what the registration looks like. And if I zoom on this, it gives me a little bit of JavaScript. So we can use that. So take the JavaScript here, copy it, paste it, and then we can look at it. Okay. So first, it says, does this client, so does this browser support passkeys? Which is not always the case, right? If you're using IE6, I'm pretty sure there are no passkeys in there. There's probably no JavaScript either. So, but we're going to be using Firefox or Chrome or a recent version, so I'm not going to handle the case where it doesn't exist. And then it's going to create this public key object, which I'm going to call options. And these are the options that I'm going to pass, that me, the website, I'm going to pass to the authenticator, to the physical device, so that it generates a key for me. So first, there's this challenge thing, and the challenge should be created on the server and be securely linked to the person who's trying to add the passkey. For ease of presentation here, we're going to make a fake challenge, and we'll make a real one in the authentication ceremony. So in this case, the type must be a uint8 array. So we're going to make that from a string. Trust me, I'm an engineer, with 2 E's. And then you have to make this into int shard code at 0. Okay, so this should be generated on a server. If you want to verify some stuff about the authenticator, in this case, we don't really want to, it's fine. Then there's information about the relying party, about the website who's trying to log you in. And so it has a name, and the name, we're going to call it WebAuthN demo. It also has an ID, a relying party ID. This relying party ID is the domain on which this app is running. So in here, it's going to be localhost. By default, it takes whatever is in your browser. So your browser looks at the URL, it says it's localhost, so I'm going to use localhost as a relying party ID, but I don't need to specify it here. And then information about the user, because potentially these devices, especially the physical ones, they can create keys for multiple users. If you want to log in as Alice and Bob using the same key, you can tell it, generate a key for Alice, generate a key for Bob, and when you're going to be clicking it, it will tell you, do you want to log in as Alice or as Bob? And so the info you have to pass to the authenticator is the email, or an ID, and then a display name. And I'm going to use username here for both. This is fine. This, and then a username. So these are actually displayed on the page in here, right? Username and email. So I can use them in JavaScript. This weird notation is it's using Spring and Timeleaf. So this is Timeleaf injecting data into JavaScript. So this is basically going to be a uint8 representation of my email, and then this is going to be Daniel@VDZ. And then you can tell your authenticator how you prefer your private and public keys, which crypto algorithms you want to use. And so here in the sample, they give you an example with elliptic curve with SHA-256, and also RSA with SHA-256. The spec recommends you use this. The reason why you put multiple algorithms is that they have different security properties, and 2, some authenticators may not support everything. The spec recommends you use ES256 here, so we're going to remove everything that's not ES256. And I want you to take a second to revel in how good this is of a user experience. ES256 obviously is ALG-7. Right? It's very, very obvious. But this is what the spec says. The signing algorithm is -7. Sound good. And then, of course, in the spec, there's a table that tells you what is supported out of the box, what are the magic numbers, because I think RSA is -257 or something like that, right? Obviously. So, you just have to go with the flow and take whatever they give you. And then a little bit of data, which is called authenticator selection. And this authenticator selection is in the case when, like me, you have 2 crypto keys, 1 TouchID, and then the phone. And so they have different properties. So for example, these keys, they're called roaming authenticators because I can put them in my pocket. And then the ones who are attached to my device, which I can't show you like this, they're called platform authenticators. And so you can say, oh, I want a platform authenticator, or I want just roaming authenticators, or both. You can tell it, do I want user verification? User verification is, do I want to know something about the identity of the user, usually about with biometrics. So the identity is not sent to the server, but it's used to unlock the private key. So you can say, oh, well, you know, I don't want biometrics, or I require biometrics, and the default is preferred when it's available, run biometrics. Otherwise, with these keys here, they're not biometric, they're just click the thing and maybe put a pin. So no user verification. Then a timeout. The timeout here is about the pop-up you saw, right? You saw a pop-up where it tells you click the button and do your fingerprint dance. And so the timeout here is how long does this pop-up stay up? And depending on the ceremony, logging in versus registration, there are recommendations. Here for a demo, like 1 minute is more than enough. But you know, if someone is adding an authenticator, maybe you want to give them a little bit more time so they can run through their drawers and like find their 5 Yubikey keys and select the one they want and come back to the computer and then try and find the USB port and all of this. So timeout, let's use a minute. And then in the example, they give you exclude credentials. So when I generate a key on one of these, it will have an ID. And I will store this ID for the client. So here I know it's Daniel who's trying to log in. So I know the server, I know all the keys they have registered with me. So I could tell the browser, do not try to re-register a key that I already know, so that you don't generate, you know, you don't use space on your device to store the private key for the same website. In that case, we're not going to care about this. We're just going to generate as many keys as we want. And then it has a concept of extensions that are outside of the spec and are other specs that you can make your authenticator do more things, which we don't really care. So if we look at what we've done, basically challenge user, the RP, so that the user can know which keys they have on their authenticator when they list them, and then authenticator selection, which is optional, but let's keep it. So then with these options, we're going to call navigator credentials create, passing the options here. And then we're going to have, so this is an asynchronous function. And then once, because of course there's a pop-up, we have to wait until the full flow where the user clicks. So when there's a problem, we're going just to show something. Yeah, police light is fine. Oops, something went wrong. And then show an error. Show the error, actually, the details of the error. And then when new credentials are created, I am going to put it in the console so that we can see what it looks like. I'm also going to prepare what I'm going to send to the server. Let's say it's called payload JSON.stringify. So we can see a string JSON representation of this. It will have a name, which I put in the text box so that, you know, on the server you can see the list of your keys. And then credentials, which is going to be the new credential info that the authenticator generates for me, and print that as well. Console.log, new credential or payload. Okay, so now with this, if everything is fine, on this page here, I could type this as a test, open the DevTools, click register. So in here, it says that you can do it with TouchID. I'm going to use a security key here, and I'm going to use this one, which doesn't have a pin. So when I just click, it does the generation. So it generates the credentials for me. And so in here, it generates this response. The response has two things. It has client data JSON. Well, maybe that's too small. There we go. Is that fine? So it has client data JSON, and it has attestation object. Client data JSON is used to tell what the authenticator received as options, as parameters. So pb paste, let's decode that, and we base64 decode it, and then we pass it into JQ. And so this is the parameters that I used to generate a private key. So this origin, and I did call create, And then I passed a challenge, which I can also decode. And it's this thing, and it needs a little bit of padding. And then trust me, I'm an engineer, right? And this client data JSON is used in the signature by the key. The key signs this, saying, yeah, okay, I created the key for localhost, and using my private key, I show you that I have not altered the message. And then it has this attestation object, which is a big, big thing, base64 encoded, but this is not, it's not human readable. This is bytes, and this is what you have in the spec. This is what an attestation object looks like. There are several formats and everything, but what you care most about is this credentials public key and the credentials ID here. So this is the private key, the public key that corresponds to the private key, and this is what the server wants to keep. And then the credential ID is the ID, so that when I click the button, when I try to log in, I know the server knows it should try and verify with this one public key. There are also some important stuff here. Counter tells you how many times this device has signed something, so that it allows you to detect cloning of devices. And then there's a signature here that says, well, you know, okay. The signature here tells you that, you know, I prove that this is correct, and it gives you a little bit more details about the manufacturer of the key, about, you know, it's linked to this MDM server or something, which is not crucial to verify. So you're fine not looking at it. Just getting the private key, the public key, is already a pretty good step for this. So we have this, and we have to send it to the server to, well, to actually link it to my account. So I'm going to use a fetch API to an endpoint that I already created on the server. We're going to post this. Method is post. The body is payload. And since fetch is not super smart about the details of what it has inside, we're going to say the content type of what we're sending is application JSON, so that Spring may decode it. And this returns a promise, so I can return this and do one more then. There's a response here. My server is going to redirect the user. So in here, I'm going to use the redirect of fetch. It's kind of hacky to do this. You shouldn't really be using fetch for that. You should be using more of a form, but it's easier to demo, so I'm going to do fetch. Here, I'm going to be loading the account page twice, which is fine. Okay, so let's do this. And again, this is a test. I can also show you a failure mode, right? Remember, I have an alert. If I cancel here, the alert pops in, right? Abort error, the operation was aborted. This is one of the type of errors that can happen. Okay, so try again, register, yes, security key, continue, and then click, and boom. So I probably sent something that was wrong. Not supported, method is not supported. Let's see, passkey, register. I post the payload. Payload is name and credentials, and WebAuthN controller. In here, I pass credentials registration, which is the name and the credentials. Gonna try again and look at the logs, but probably. Oh, there you go. Content type is wrong, so I may have mistyped something. Account page. Headers, of course, right? JavaScript, you can type anything, obviously. All right, come again. Send this to the server. Register. Okay. Click. Boom. So this time it reloads the page, and the server should have our key, and so we should probably print it in the controller here. So this one, the credentials, I have them. I can print them. Credentials. Yeah, there we go. And so I need to save those, and I need to link it to my user. So to link it to the user, I'm going to use Spring Security for this. It knows I have a user who's logged in, right? I'm logged into that page. It has my name and everything. And so using some sort of service, I can save authenticator service. I can call save credentials and then user, right? And generate this method. Okay. And so in here, I'm going to be saving that to the repository I have. And I save, the save is a user authenticator here. So let's make a user authenticator, just null, this one. So user, yeah, fine. And how to make this? This is just my object, and it encapsulates the data I need to know. So the ID of the credential, which is sent in the request. I need to know the user, which I know from my session. I need to know the name so that I can display it to the user. And I need to know the attestation object. And the attestation object here, I'm going to make a variable for this, attestation object. So in the credentials response that the authenticator makes, there's an attestation object. It's been serialized to base64 to be able to send it over the wire. So I'm going to decode it before I store it in the database. Base64 decoder, and then I decode this and store it. All right, so we have an authenticator and we save it. Here, there's a big to-do, validate the credentials. So the security of this is kind of okay because I'm already logged in. So there's less attack surface that I can do here versus an authentication click ceremony. It's always a good idea to validate this attestation object nonetheless, because it can tell you things about, well, this is a Yubikey 5 and of this batch, so I trust it, right? Or this is just like a Chinese ripoff of a Yubikey, and so maybe I want to warn the user that it will be needing to use the second factor if they use this. So, hey, I clicked my Yubikey. And so validation is useful. It's not absolutely mandatory. Okay, so we received the thing from the browser here, and so now, if I try and register a key, this one is called Thetis, this is the brand of that. If I click this, security key, and I click now, boop, then it shows up in the list of keys, and I can register a new one. So say, for example, TouchID register. I touch my TouchID sensor on my Mac, and then a new key shows up, right? So now the server knows my public keys, and I want to use that for logging in. So let's do this. Is it okay so far? Questions? Yes. 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 So the Yubikey is kind of a. Yeah, that's true. So the question was.
I can repeat the question.
Yeah, go ahead.
You touched your Yubikey and it typed something into the standard output or so.
Yes.
Can somebody potentially hijack that and use that?
No, absolutely not. It's for some other protocols. The key is securely stored in here, inside the Yubikey. It's generated per host, and it's longer than that, right? Even if you look at the public key, I think I can show it. Database in here in the authenticator, right? Well, I guess these are bytes, right? But see, it's longer than what the public key shows, right? What the Yubikey shows when you click. I'm not exactly sure what it shows. I think these are the other protocols that are supported by Yubikey, but it's not WebAuthN. Okay, so we are able to add keys, and now when the user comes in, and instead of logging in with email, we want to log in with a passkey. So again, I have basic infrastructure here. You clicked login with passkey. Okay, so let's do the same, the same heuristic. Rather than coming up with all the details ourselves, we're going to go to the spec, and we're going to look for authentication. And in authentication, they give you the basic example. So I'm going to take that, and I'm going to put it in this landing page I have, which is the public one. And in here, I'm going to paste this. So again, if your browser doesn't support public keys, you should probably not even show the public key button. But for now, this is Firefox. It does support it. So okay. Credential ID here, there's two flows you can do for authenticating. There's one just like this one here, where the user doesn't put their username first. They just like say, I want to log in with a passkey, and then they click. And then there's another flow where the user puts their name, presses, yes, I want to log in, and then passkeys show up. If the user has put their username, you can know the keys you have for them. And so you can tell the browser only try and activate those keys. So only propose TouchID, don't propose Yubikey because it's not registered with me. In our case, we don't know the user yet, so we don't know their keys, so we don't know the keys in advance. We can't tell them, oh, just activate the Yubikey. And this goes in this allows credential. So for us, we're going to let the browser discover which keys are available and then let the user use those keys. Again, a timeout. And then a challenge. And in this case, the challenge is very important. In the registration, less so. In this case, this is the thing that proves it's actually me. So I need to pass an actual challenge. So I'm going to make a variable in the server, and I'm going to consume it here. Char code at 0. And this is lambda to transform strings to the challenge. Okay, the challenge string to a uint array, which is like this. Okay. And so this challenge on the server, how do I generate it? Well, it's a Spring app. So there we go. In here, I can add the challenge to my model so that it's consumed by the templating engine challenge, and I can make something random. Now I want to be sure that the user who actually clicked has signed the challenge I want, because the signature is not enough. Because someone could intercept my attempt to log in, and they could try and replay it. So I want to generate challenges every time someone wants to log in. So I need to do one per user who opens this page. And so I'm doing one here, but then I need to verify when the post happens. So this needs to be stored in the user session. The way you do this in Spring, you could do it with the session attributes decorator, and you say every time you add challenge to the model, also put it in the session. And so it can be consumed on the other side. Okay, so we have a challenge, and then we call credentials.get instead of creating credentials create. And we're going to do something very similar to the landing page, to the account page when we do registration. So something that kind of looks like this. Oop, I'm going to take this infrastructure of doing a fetch, right? There we go. And instead of sending the payload this time, I send the assertion. This is what I'm sending to the server, right? Okay. And the server needs to consume this request in the register endpoint. Register, it's in WebAuthN controller, this one. So the register endpoint is here. The login endpoint, sorry, not register. My bad, right? Because I'm trying it to log in, not to register. And so the login endpoint takes the credentials. I could display them, but it also needs to take a few things. It needs to take the challenge to validate it. Challenge. So what is in the user session that is called challenge? So I can compare with the signature that comes in. And I'm also going to pass this session status thing, which is a Spring, decorator or injected class that I can call set complete, so that it deletes the challenge from the session. So I'm consuming the challenge here. And with this, I need to validate this. So I need to make a function that in my authenticator authenticates the credentials with the given challenge. And hopefully I would want this to return a user to me, right? And then I'm going to log the user in with Spring Security using login service, okay? So we have to build this authenticate function. Boom, credentials, there we go. And so in here, we do want to validate the credentials. This is the most important part, right? Because we don't want someone to just send a random signature and we trust it. So you could do the crypto yourself and like go and find this out. But then you find this is a COSE key, and then COSE is actually like 100 pages of spec, and then the C in COSE is CBOR, like compact binary object representation, another 50 pages. So my recommendation here is use a library that does that for you. So in here, I'm using this library called WebAuthN 4J. Maybe this one here, okay? So it's it's, you know, it's just a library to do that in Java. Caveat, it's maintained by this one dude. But he's very, you know, he actually takes time to do it. But it's better than rolling my own thing. So in here, it gives us a WebAuthN manager, and I need to validate, validate some things. And these are their domain objects, right? So I'm gonna cast this to, this is an authentication request, their domain object, and we need to build that, this one, authentication request. There we go. And then this is a authentication parameters. So what is an authentication request? Authentication request. We look at the constructor, we look at the simpler one, and it takes these things. So let's see what this is. So credential ID, this is in the credentials. There's an ID, but it's base64 encoded. So again, you need to decode it to get the bytes. Fine. Authenticator data.json, it's basically the same, right? It's in the payload here. There's a response, and the response has authenticator data. Client data.json, which tells the website that, you know, I signed the challenge blah, and I did it for this origin. And then the signature, the result of the crypto that the authenticator does for me. And then this authentication parameters, again, a domain object, and we can look at the constructor. And it takes three things, these three things. There we go. So 3 things. Server properties. Basically, this is what you expect. So client.json is what the authenticator tells you it's signed, and then you have to compare it. But is that really my address? And is that really the challenge I sent? And so in here, basically, you need to pass the domain or the origin that you, the server, are, and the challenge. And, you know, it has a little bit of mangling to make the right objects for the library. And then the authenticator object that it requires, and this is the attestation. So the attestation here is the thing we've saved in the first bits of, I don't know why it puts the empty thing here. Let's put it here. Okay, in the repository, we can find by ID the thing that we have saved. I trust that there's one. It has an authenticator, fine. And so this is the object we've put in our database. And this one, if you remember, we put the bytes of the attestation. And lastly, you tell it, well, do I want to verify the user with what's it called? With biometrics. So no, I don't care. If you click the button, it's fine. And here you validate, right? And this can fail, right? With data commercial exception, validation exception. If it doesn't fail, return the user that is linked to this credential, right? So hopefully, if I'm not missing a semicolon, thank you, IntelliJ. There we go. Hopefully, if I go back to my demo, I click login with passkey, and I click this thing, boop, I log in. And again, you know, you can log out and you can do it again with any passkey that's registered. Here, I'm using my Mac, TouchID, which does biometrics, works as well. If someone sends me a wrong signature, it blows up. It should blow up. Fake, this goes in here, plus, you know, pirate, whatever. So if someone sends me a pirate signature and I try and log in, yep, log in with passkey, try and log in, here it should blow up in horrible ways. Of course, it does. And so in here, if you looked at the stack trace, it would tell you somewhere like, oh, this signature doesn't match the assertion because, of course, I added pirate. You know, well, it's in here somewhere. There we go. It says, oh, well, not enough valid bits because I put a wrong signature, but whatever. If I took the time to put a signature that's wrong in here, it will blow up with a better error message. So to conclude this thing, observations, it's actually quite complicated. So implementing this yourself, I wouldn't recommend it. We've ran through it to see the mechanics of it, but we're missing some data that we should validate. So there's a little bit more validation to make. There are, you know, corner cases, what if someone opens multiple pages and so on. So use a library. Even with a library, it's complicated, as you've seen. So really define the use cases you want and cover those only, because the spec is very wide. It covers many things. What you want is only some smaller use cases, and then read up on it, because it as I told you, even with the library, it's very complicated. So the Yubikey website, great for that. And this is coming soon in Spring Security, so there will be support for this, maybe in 6.3, maybe in 6.4. I can't really tell you, but in the next 6 months, we'll have at least initial support for that. Thank you. That was a lot of content, and not everything worked, but here's the repo. Feedback, I think the feedback is actually the wrong thing, but you'll find me on the app. And if you have questions since time is over, come meet me in the hall, send me emails. I'll be very glad to chat with you. Thank you.